Students, I welcome you again to the surface chemistry chapter, and we are reaching to the end of the chapter. Only 2 or 3 more lectures and we will be done with this. And after surface chemistry, I will be starting organic chemistry with you, and that will be alcohol, phenols and ether. So before that, let's go through the today's work. Let's see what we have today. Today we have a few phenomenons which we are going to study. These all phenomenons belong to surface chemistry. The first of all, the first one is Tyndall effect. What is Tyndall effect? Tyndall effect, for example, in a closed room, in a dark room, you have a glass, and in that glass you have some colloidal solution. Okay, so what you do, with the help of a torch, you put or you pass beam of light through the solution. If the light gets scattered, it is known as Tyndall effect. So what is Tyndall effect? Scattering of light is known as Tyndall effect. So when a beam of light is passed through a colloidal solution, the path of the beam becomes visible. It is called Tyndall phenomenon. It is due to the scattering of light by colloidal particles. Here we have to understand that true solutions will not show Tyndall effect. Why? Because in case of true solution, the particle size is less than 1 nanometer. So when the size of the particle is less than 1 nanometer, it will not scatter the light because the light will pass through. Only colloidal solutions and suspension, in which the size ranges from 1 nanometer to 100 nanometer in colloidal state, and then 100 and above in suspension, they will show Tyndall effect. So finally, what is Tyndall effect? It is the scattering of light or beam of light. That is, when a beam of light is passed through a colloidal solution, the path of the beam becomes visible. Next, number 2, we have electrophoresis. It is very easy. Electrophoresis is that phenomenon in which the colloidal particles get deposited to the opposite pole. As we know that colloidal solution consists of dispersion phase and dispersion medium. So always colloidal particles, they carry charge. So particles of a colloidal solution possess positive or negative charge. When such solution is placed in an electric field, the colloidal particles migrate towards the oppositely charged electrode. This movement of colloidal particles is called electrophoresis. So what is electrophoresis? When the oppositely charged colloidal particles move towards the opposite pole. This phenomenon is known as electrophoresis. Next, we have brownian movement. I have told you brownian movement in my last lecture also. I told you how Mr. Brown was sitting near the pond and he was observing that pollen grains which were present over the surface of a liquid, they were constantly moving from here and there. Instead, despite the pond was stagnant, the pond water was stagnant, it was not moving. So what was causing that movement? That movement was caused by particles itself, and the zigzag movement is known as brownian movement. I'll read it. Brownian movement is the random or zigzag motion of the particles of the dispersed phase of the colloidal solution. It is due to irregular bombardment of the particles of the dispersed medium on the particles of dispersed phase. Brownian movement is responsible for the stability of colloidal particles. So, in short, we can say, so Brownian movement is just movement of particles from here and there. Even they can collide to the surface, and even they can collide to each other with each other. That is collisions. Collisions can be effective, collisions can be ineffective. More is the Brownian movement, stronger will be the stability of the colloidal solution. Keep it in mind. The next phenomenon, we have electrodialysis. I just discussed with you electrophoresis. In electrophoresis, what I told you? I told you that all the colloidal particles are charged. So on that basis, we are going to understand what electrodialysis is. The method of removal of soluble impurities from soils by the semi-permeable membrane is called dialysis. Dialysis is based on the principle that soil particles cannot pass through parchment paper or cellophane membrane, but particles of true solution can pass through these membrane. In order to purify a soul, it is filled in a bag made up of parchment paper or cellophane membrane. It is then suspended in fresh water. The particles of electrolyte pass out, leaving behind pure colloidal soul. The movement of ions across the membrane is expedited quickly by applying electric potential through the two electrodes. This method, which is faster than simple dialysis, is called electrodialysis. So let us understand electrodialysis deeply. What is it and how it happens? Suppose you have a parchment bag or cellophane bag. You fill a colloidal solution into it, and the colloidal solution which we have filled is impure. How we can pure this colloidal solution? Simply, we have to take a container, we have to fill it with water, and after that we have to put this cellophane bag inside the container filled with water. So what will happen? The impurities are in the form of true solution. Their size is less than 1 nanometer. So now their size is less than 1 nanometer. They can easily come out from the parchment bag. But colloidal size is more than 1 nanometer. They will stick inside the bag itself. They won't come out. So all the impurities which are true solutions, they will come out of the bag, and gradually the number of colloidal particles will start increasing inside the bag. Or in other words, we can say that with the passage of time, whole of the impurity will come out of the bag and you will get a pure colloidal solution. Now this process of dialysis is a bit slower. To increase the process, what we do, we put two opposite electrodes across the bag. As you know, colloidal particles are oppositely charged. So when we put the oppositely charged electrode across the bag, what will happen? The dialysis will be fast enough, it will speed up, and the purification process will takes place very steadily and fastly, and finally we can obtain the pure colloidal solution instantly. If we carry out dialysis, the process is slow, but in case of electrodialysis, the process is very fast. Now we come to the last topic, that is factors affecting adsorption of a gas on solid. So what are the factors which affects the adsorption of a gas on solid? I have already discussed with you in, I think, second or third lecture. So kind of we are revising today. The first is nature of the adsorbent. If easily liquefiable gases like ammonia, HCl, carbon dioxide, etc. are adsorbed more readily than the permanent gases such as H2 and 2. Those gases which are unstable, they will get adsorbed faster as compared to stable gases. Number 2, nature of adsorbent. Solids like charcoal, silica gel, which have large surface area, have better rate of adsorption. Number 3, effect of temperature. First of all, as we know, mostly adsorption processes are exothermic. Hence, adsorption decreases with rise in temperature. For endothermic adsorption processes, adsorption increases with increase in temperature. That is, in case of chemical adsorption, the rate of adsorption increases. But in case of what we call physical adsorption, the rate of adsorption decreases with increase in temperature, because in case of chemical adsorption, chemical bonds are involved. But in case of physical adsorption, physical bonds are involved, which breaks easily with increase in temperature. Now let's come to the next point, that is the last point, pressure of the gas. See, rate of adsorption is directly proportional to the pressure of the gas. More is the pressure, more will be the adsorption rate. But keep it in mind, if we keep on increasing the pressure, we will reach at a point which is known as saturation pressure. At this point, the rate of adsorption will become equals to the rate of desorption. Hence, we can say there will be an equilibrium between rate of between adsorption and desorption. For example, at saturation pressure, if 5 molecules are getting adsorbed, that is, if 5 molecules are getting adsorbed on the surface, simultaneously 5 molecules will leave the surface. So the net results will be 0. No matter how much more pressure we will apply, the adsorption rate will not increase. Today's lecture is done. Please revise every lecture which I have been giving you from number of days. Remember, You have to study hard because we are in plus 2 medical and non-medical. We have to study every day because we are going to get very less time for the board examination. Please revise all the lectures which I have been giving you from number of days. Write them in your school notebook copy and keep on revising them. Thank you.